Hello everyone, welcome to this next question on classical mechanics. This question appeared in June 2011 and it consists of 3 marks. The question says, which of the following is correct? It is given that the first option, a free particle in R cube can have infinite degrees of freedom. So let us look at this case. We have a 3D space R cube. So this is our R cube and we have a particle over here. Now this particle can move either in this direction or in this direction or in this direction independently. Right? Say this is X, this is Y and this is Z. So now if a particle tends to move in some random direction, this one, then it would definitely be some function of either X or Y or Z. So in that case also you can specify the motion of this particle in terms of these 3 coordinates only. So these are the 3 independent coordinates which are required to specify the motion of this single particle. Therefore, a free particle in R cube can have 3 degrees of freedom, which is a finite number. Therefore, this option is incorrect. Now talking about the second option, they are saying number of degree of freedom of n particles is greater than 3n. So let us discuss this case. We assume that the system of n particles is represented in this 3-dimensional space. X, Y and Z, we have n particles over here. These are n particles. So now we have seen in one of the videos which are present in this playlist on classical mechanics, we have seen that we can convert this system into a configuration system in which we have 3n axes. And so you have this x1, x2 and xn, similarly y1, y2 up to yn, and you have z1, z2 up to zn. So this is the coordinate system, and then you can specify n particles into this system as a single particle. This is known as the configuration space. So the degree of freedom for this particle in this configuration space is exactly equal to 3n, because there are n particles and these are specified in these 3 independent directions. Therefore, the number of degree of freedom is not greater than 3n, but it is equal to 3n. So this option is also incorrect. Now coming to option number 3rd, we are saying a system of n particles with k constants has 3n plus k degrees of freedom. Now this is the system of n particles. We know if we have a system of n particles, and so its degree of freedom are 3 is equal to 3n when it is completely free. But now they are saying we have k constants or k constraints acting on it. So if our constraint is of this form, say ax plus by is equal to 0, and x and y, they are the independent coordinates, then in that case you can write x as minus by upon a. So you have just expressed this x in terms of y over here. Therefore, now your 2 independent coordinates, they have reduced to only 1 independent coordinate. So similarly, if you have k such conditions, we had 1 condition, so a number reduces from 2 to 1. 2 minus 1 is 1. So here in this case we would have 3n minus k degree of freedom if we have k constraints acting on the system of n particles. So therefore this option is also incorrect. Talking about the 4th option, a system consisting of 3 point masses. So we have one mass over here, second mass over here, third mass over here, and they are connected by 3 rigid massless rods. So this particle is connected by this through a rod, this through a rod, and this through a rod. So now they are saying it has 6 degrees of freedom. Now can you see this particle? It can either move in this direction or in this direction because they are connected, and it can also move in this direction because in total we are talking about 3-dimensional space. So for this particle we have one direction as this one direction as this one, and one direction as this one. For this particle, we have one direction as this one direction as this one, and one direction as this one. So in total we have, and for this particle, we have this direction, and this direction. Therefore, in total, how many degrees of freedom do we need to specify this system completely when these 3 points, they are joined together with each other? So can you see, this is one direction, this is second direction, this is third direction, this is fourth direction, this is fifth direction, and this is the sixth direction. So overall 6 degrees of freedom are required to specify a system of 3-point masses which are connected by 3 rigid massless rods. So option D is the correct option. I guess this question is understood by you. Well, thank you for watching the video.